Today we're going to simplify exponents using a variety of properties. We're going to investigate 5 different properties here using expanded form, and then we're going to practice the new skill that we learned. So first, I have x to the second times x to the fifth. X to the second I know can be written in expanded form as x times x. Now that's also multiplying x to the fifth, which can be written in an expanded form as x times x times x times x times x. I have repeated multiplication of the same base, and this means my final answer can be written as x to the seventh, since it's x multiplying itself 7 times. If you noticed that the two exponents, 2 and 5, were just added together to get 7, that's the shortcut. So if we're multiplying and the bases are the same, our shortcut tells us that we can add the exponents. Let's practice that with number 1. So on practice example number 1, I'm multiplying and my bases are both a. Since my exponent is 3 and my exponent is 8, that means my final answer is going to be a to the 11th power. If I were to expand this out in the same way, I would have had 3a's multiplying itself times 8a's multiplying itself for a total of 11a's multiplying itself. Let's try example 2. Example 2 I like to think of as almost 3 mini math problems. So the first problem would be the two numbers that I see that don't have variables and exponents. Then I've got my x's, and then I've got my y's. So I'm going to approach these as 3 completely separate problems. So my first problem is to do the number 4 times the number 5, which would give me an answer of 20. Then I'm going to do x to the second times x to the 8th. Since I'm multiplying and both bases are x's, my shortcut tells me I can just add their exponents to get x to the 10th. I can also visualize this in expanded form, which would have been 2x's multiplying itself and 8x's multiplying itself for a total of 10x's multiplying itself. Now I can multiply my y's, so y times y to the 4th would be y to the 5th. One reason is this expression of y has an exponent of 1, even though we don't see it, and 1 plus 4 is 5. And in expanded form, I would see 1y and 4y's for a total of 5y's multiplying itself. So this final answer would be 20 x to the 10th, y to the 5th. In situation B, instead of multiplying, I'm now dividing. So I'm going to expand this out again. So for x to the 5th, I know that means to do x times itself 5 times. And that's the numerator of my fraction, and my denominator is x to the second, which means to do x times x. Now remember, when we're dividing, anything divided by itself is 1. So what that would mean is that everywhere I see an x on top and an x on bottom as a pair, I can cancel them out and create the number 1. And I can do that again with my second pair. So now on the top, I've got 1 times 1, which is 1, times x, which would be x, because anything times 1 is itself. So on the top, I've got x times itself 3 times, which would be x cubed. And on the bottom, all I'm left with is the number 1, and so my final answer could just be written as x cubed, or x to the 3rd power. Now if you're noticing, hey, 5 and 2 can be subtracted to make 3, you recognize the shortcut. Now remember, with the previous example, when we were multiplying, we added 5 and 2. Logically, that it would make sense that since division is the opposite of multiplication, that we would subtract, since that's the opposite of addition. So let's practice that here with our y's. So that would mean y to the 7th divided by y to the 3rd. If I want to apply my shortcut, I could make it y to the power of 7 minus 3, which is 4. If you could picture this in expanded form, y to the 7th would mean you have 7 y's in your numerator. Y to the 3rd would mean you have 3 y's in your denominator. 3 of them would cancel out, leaving 4 extra y's on the top. Let's try this with practice example number 2, but again, let's separate it into 2 separate problems. So the first problem that I see is just 4 over 8, and the second problem that I see is x to the 8th over x to the 7th. So I'm going to try to ignore my x's for the moment, and the fraction that I see is 4/8. And so what I can do is I can simplify that fraction by dividing top and bottom by 4 to get 1 over 2, which makes sense. A fraction of 4/8 is going to simplify to 1/2. So I've got 1 over 2. Now I still have my x's. I've got x to the 8th over x to the 7th. I could apply my shortcut for dividing these x's, which allows me to subtract my exponents, and so I'd be left with x to the 1st, or just x. Now the reason that x is going to be in my numerator is because I have 8 x's in my numerator, 7 x's in my denominator, which means I have more x's on top and I have 1 extra. So if I were to expand these out all the way, stretch the accordion, I would cancel out 7 of my 8 x's, leaving 1 behind. So my answer could look like this, 1x over 2. You might also just see it as x over 2, and this would be fine as well. Let's look at our next situation. So in situation C, I want to look at my outermost exponent of 5. Remember, my exponent tells me how many slots I should draw. I'm going to draw 5 slots because an exponent of 5 means repeated multiplication 5 times. That exponent of 5 happens to be touching everything inside the parentheses, which is x squared. So that means on these lines, I can write x squared, because this literally means to multiply x squared by itself times 5 times. But remember, everywhere I see an x squared, that actually means x times itself. So I could expand this out even further, and all of these were multiplying themselves. And so now I can see I have 2, 4, 6, 8, 10 x's multiplying itself, which can make my final answer x to the 10th. So if you're seeing that you've got, hey, 5 and 2, and I can multiply those to get 10, you've come across the shortcut. If you're raising a power to a power, you can multiply your exponents. So let's practice that here. So a to the 2nd to the 4th power would mean that I could do a to the 8th, because this would really mean 4 slots with a squared on each slot. I could think of this in 2 different ways now. I could say, well, I'm multiplying, and my shortcut was to add. 2 plus 2 is 4, plus 2 is 6, plus 2 is 8. Or I could think of these each as 2 a's that could be expanded out even further. And if I did that each time, I would have a total of 8 a's multiplying itself. Let's look at the next practice example. So again, I like to break it up into mini math problems. I've got a 5 inside the parentheses, I've got an x to the 4th, and I've got a y squared. And my outermost exponent is 3. So what this outermost exponent would mean is that I'm raising every single item inside the parentheses to the 3rd power. So that means I'm raising 5 to the 3rd power, x to the 4th to the 3rd power, and y to the 2nd to the 3rd power. And so I can do each of these problems individually. 5 to the 3rd power means to do 5 times itself 3 times. So 5 times 5 times 5. 5 times 5 is 25, times another 5 is 125. X to the 4th to the 3rd, power to a power. My shortcut tells me I can multiply my exponents. X to the 12th. Y to the 2nd to the 3rd power. Again, my shortcut tells me I can multiply my exponents. Y to the 6th. My final answer is 125, x to the 12th, y to the 6th. On this next one, I've got x times y being raised to the 5th power. So again, my outermost exponent tells me that I can draw 5 slots. 1, 2, 3, 4, 5. And since that exponent is touching the parentheses, that means that everything inside the parentheses is being raised to the 5th power. So on each slot, I can write x times y. Now remember, since the only operation within this problem is multiplication, and multiplication is commutative, what I could do is I could kind of swap everything and put it in the order that makes sense. So I could do all my x's first, times all my y's second, for a final answer of x to the 5th, y to the 5th. And so what we can see that happened here is that both items inside the parentheses received the 5th power. Actually very similar to what happened to this practice example over here, where each item inside received the 3rd power. Why don't you give example 2 a try on your own? Pause the video, press play when you're ready to check your answer. So according to my outermost exponent of 5, I should draw 5 slots. And on each slot, I should write the base, which is whatever this exponent is touching. Now, since it's touching the parentheses, that means everything inside the parentheses is being raised to the 5th power. So on each line, I drew x to the 3rd times y squared. Now then I tried to actually expand these out, but I realized that I was running out of room. So you could, at this point, you could think about it expanded out, which would be 3x's, 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 and 3x's. That would be 15x's. Or remember, you can apply your shortcut when you're multiplying all these x's. You're allowed to add your exponents. So 3 plus 3 is 6, plus 3 is 9, plus 3 is 12, plus 3 is 15. Similarly for y, they're being multiplied. 2 plus 2 is 4, plus 2 is 6, plus 2 is 8, plus 2 is 10. Or you could expand it out to see it more. Pause the video to try these 2 practice examples. If it helps, you can expand it out, or you can think about how many slots you need to draw. Either way, when you write your final answer, you want it to look like a nice, clean final answer with one variable per exponent and no parentheses left. Pause the video, press play when you're ready to check your answers. So on number 1, the exponent of 9 is touching the parentheses, which means both the a and the b are receiving or being raised to the exponent of 9. So a to the 9th, b to the 9th. On number 2, the outermost exponent of 2 is touching everything inside the parentheses, so every single thing inside the parentheses is being raised to the 2nd power. So the first thing is 4 to the 2nd power, which means 4 times 4, and that's 16. X to the 8th to the 2nd power. Power to a power tells me I can multiply my exponents, so the resulting exponent of x is going to be 16. And y to the 3rd to the 2nd, power to a power, I can multiply my exponents, and 3 times 2 is 6. Our last rule is very similar to the one we just looked at, it's just for division. So same idea, this exponent of 5 is touching everything in the parentheses, so that means that x over y is being multiplied by itself 5 times. So I could draw 5 slots. Now since I have a fraction, I'm actually just going to pretend that's a fraction bar. And so my base is x over y, x over y, x over y, x over y, x over y. Now remember, when we multiply fractions, we just multiply straight across. And so x times itself 5 times would be x to the 5th, and y times itself 5 times would be y to the 5th. And it's important with this, a lot of people like to kind of just move the y up, but y is in the denominator of the fraction, so we're going to leave it there. On the next one, very similar again, I'm going to draw my 5 slots for my exponent, 1, 2, 3, 4, 5. And then on each slot, what I can draw is x to the 3rd over y squared, 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 x to the 3rd over y squared. Wow, those words are starting to not have any meaning. And when I multiply straight across, since all these exponents are all these x's on top are multiplying each other, I can apply my shortcut. 3 plus 3 is 6, plus 3 is 9, plus 3 is 12, plus 3 is 15. So my numerator would be x to the 15th, and my denominator would be y to the 10th. So you're going to pause the video, try these practice examples 1 and 2, press play when you're ready to check your answers. So on number 1, my exponent of 9 is being applied to everything inside the parentheses, so that means both a and b are being raised to the 9th power. Now b just happens to be in the denominator, so we're going to keep it there. A to the 9th over b to the 9th. On example 2, everything inside the parentheses is being raised to the 2nd power. So the first thing is x to the 7th to the 2nd, power to a power. I can multiply my 2 exponents to get x to the 14th. The next thing I'm raising to the 2nd power is y to the 6th. Now remember, it's in the denominator, so it's going to stay there. Y to the 6th to the 2nd power is going to be y to the 12th. There will be times in the future where things are going to get to jump from numerator to denominator in the fractions, but we're not quite there yet.